Hi guys, Dr. B here. This lecture, this video you're watching is just a continuation slash review of what we covered in class for A Day and B Day. Kinematics is the branch of mechanics that studies the motion of a body without caring what caused the motion. So we've been talking about one-dimensional kinematics, 1D, one-dimensional. So that's either, quote unquote, left or right or up and down. Two-dimensional, however, takes into account both kind of like an x-axis and a y or a y-axis, but two-dimensional actually does x and y. It takes both of those into account when you're looking at it. So some physics quantities you should be aware of, and the term scalar and vector. We talked about this in class. So a vector has both a size and a direction, while a scalar only has a size, or a magnitude, if you will. Also remember that vectors can be positive or negative. That's just in reference to the direction. Scalars, however, only have a size or a magnitude, like a number associated with it. So in terms of mass versus weight, we talked about how mass has no direction, so it's a scalar quantity, and it's only focused on the amount of matter in an object. However, weight takes into account gravity, pulling down towards the center of the earth. That's why it makes weight a vector. So if you're on the moon, your mass would probably be the same. It would be the same because you take up the same amount of space in terms of matter, but because there's less gravity, less of a pull on the moon, your weight would be less on the moon technically. So vectors, they're often represented by arrows. How far, how strong, the magnitude of the arrow, the length of the arrow, can represent how far something goes, how fast something goes, and the arrow is pointing in the direction of the force, the motion, of the displacement. So like we said, we were dealing with one-dimensional, but notice how this takes into account angles. That's what makes us two-dimensional. So some units and quantities, some of you should already know, but I think the important thing from this slide to take away is that a quantity and a unit is not the same thing. So if I said, what is the symbol for displacement, not the symbol for the unit, but the actual symbol for displacement, you would tell me the delta x. Because displacement is your final position minus your initial position. So of the quantity displacement, the symbol is delta x. But if I said what is the unit of the standard unit would be meters, and the symbol for that would be m. So some kinematics definitions to be aware of. Kinematics is a study of motion, positions where you're located at, your distance is how far you have traveled regardless of the direction, and then the displacement delta x is where you are in relation to where you started. So you could have a negative, it's ugly, a negative displacement because it's in relation to wherever you started from initially. So how to represent motion? You can have motion diagrams, and just looking at this, you can see on the left that's a car stopping or slowing down based on these snapshots in time, if you will. So you can see that there's a decreasing distance in between the images as the object is slowing down. If a cyclist starts a race, it's kind of the opposite, right? Because you're you can tell they're slowly going faster because the distance in between each is increasing. You can say at each second, if you will, or each time frame, this cyclist is kind of starting off slow, and then eventually they're speeding up by the increasing of the distance. These are 4 types of motions we're going to study. Straight line motion, which we're talking about now, circular motion, projectile motion, and rotational motion. So all of these all fall under kinematics, but there's different aspects to it, or different types. So examples of motion diagrams. So you can kind of see how we're going to use something similar to kind of demonstrate or show motion. So the first one shows a ball that's kind of in the same motion in all 4 frames. Basically, what you see is that this object is at rest. It's not moving at all. If you see this person right here that's skateboarding, if they're equidistant or equally spaced out, that means that this person, this object, skateboarder, is moving at a constant speed. If you can see that from here to here to here, there's an increasing distance in between each image, and that can demonstrate how somebody is speeding up. It's kind of like before, if the distance between each image is decreasing, that means that that object or that person or that thing is slowing down. Throwing basketball, a basketball free throw, you can see it's a little more complex because it's taking into account projectile motion like that. So what does this have to do with anything? So it's related to something in physics called the particle model. And it's a model that we can use to kind of treat an object as if all of its mass is in one dot, right, a single point. And that helps us to focus on the overall motion of the object. So between each frame, the same amount of time is elapsing. So it can be a second, can be a minute, for example, whatever the case may be. But what we're focusing on is that the amount of time, so basically if for this one, the distance between each is the same amount of time, but it just shows you that the distance between each is getting smaller because the car is slowing down / stopping. So the position of an object is located on a coordinate system. So kind of like your X and Y axis, if you will. But for now, for what we're doing with this one-dimensional kinematics, right now we're just focusing on the X, if you will. At each time, whatever the case may be, the object is at some particular position. So let's say that if we're interested in the entire motion of the car, for a car going, we can say that at 0 seconds it's here, 1 second, 2 seconds, 3 seconds. Based on this, you can kind of see that if you're looking at the car, as the time is increasing, the distance is decreasing. That means that the car is slowing down based on this particular particle, this particular point, etc. So a particle, why is it called a particle model? Because it has a position and a particular mass. We're not looking at size or volume, but we're just saying that at this particle, which has a position and mass, is located at one point in space. And a position is a location of a particle in space. So in one dimension, like I said, it can be on the X or Y axis, but if it's 2 dimensions, you have to take both into account. So for example, let's say we have this point right here. Its position is x equals 1m. So this is kind of what we did with the cars in class. So again, this is kind of review, but just kind of keep in mind, like the coordinate would be x equals 1m, if you will. So distance, what exactly is that again? It is the total length of the path traveled by an object, and it does not depend on direction, so it can't be negative. This is a scalar quantity. Kind of like how far have you walked today? Your displacement, however, is a change in position of an object. That's the official definition. So it depends only on the initial and the final positions. It includes direction. Remember that it's represented by delta x, where xf is your final position and your xi is your initial position. So you subtract the two. Xf minus xi will give me my displacement, my delta x. So when you saw that before, what is that? What are those little numbers, those tiny letters, whatever you want to call it, at the bottom of each variable? These are called subscripts. And the thing with subscripts is that it helps to explain whatever it is we're talking about. It helps to denote and describe whatever it is. So if you see that I and the F, most likely it's the initial or the final. Kind of like if I said my change in time is TF minus my TI, for example, that means my final time and my initial time. Again, these are just other examples. So 0 actually can denote something called naught or starting time.